Okay. Next up, we have Josh Triplett and Jessica Mars.
And I will get that to you.
Okay. All righty. So we'd like to talk to you a little bit about licensing open hardware as opposed to just open software. So I'm Josh Triplett. This is Jessica Mars.
Hello.
We're going to, I want to start off with some of the standard disclaimers. I am not a lawyer. Jessica is a lawyer, but is not your lawyer. And neither of us are speaking for any company, organization, or any other entity that we may be a part of. We will assume if you ask questions, you're not either. This is not legal advice. Our experience is primarily with U.S. law, so that is where our citations are. Many of the things we're mentioning and talking about do apply globally or to numerous countries based off of various treaties, but we would certainly welcome any corrections or commentary from people experienced with the international equivalence or other related law. And please do feel free, if you've got an urgent question or commentary, to make this more interactive and have a discussion. Otherwise, feel free to ask questions at the end as well. So, as I said, I'm not a lawyer. My primary day job is that I'm a software architect. So let's talk about software architecture first. So there's a lot of ways you could put software together. You can put source code into the same source file. You could link object files or libraries together from multiple object files or multiple separate libraries, shared or static. You could fork and exec a process. You could create multiple independent servers, communicate via remote procedure call, communicate via sockets of some kind, even over a network. You could have a shared memory architecture between multiple processes. You could have some standardized APIs for talking between multiple programs for which multiple implementations exist. And one interesting distinction here is that these various distinctions don't matter massively from a legal point of view if you're using permissive licensing. If you're using a license that says do whatever you want or do whatever you want as long as you give me credit for it, then it doesn't really matter how you put your software together. You can do whatever you want. But where those distinctions start getting interesting is when you start using copyleft licenses. In that case, there is an intent that you're trying to provide of saying, this is the scope that I consider this license to extend to. And there are various licenses that extend that scope to varying degrees on a spectrum. You've got the LGPL, which extends it to the case of linking multiple objects together, but allows some more flexibility and more free passes if you're linking dynamic libraries. You've got the GPL that extends through dynamic libraries and up to some other boundary, details to be determined, see various courts in the future. You've got the AGPL, which will extend that out through servers of various kinds. And the point is not to say this is where the boundary should be drawn. It's to say there are many interesting points you could draw that boundary on based off of your goal and your intent. One point I want to make here is we're not claiming in this talk to have all the answers. Our hope is that we have almost all of the right questions and then some plausible set of answers that we can talk to you about. So that's software architecture and software copyleft, and that's been, while it may not be perfectly explored in case law at this point, it is certainly something that has been well trodden by many a software engineer and lawyer for the last several decades. So let's talk a little bit about hardware architecture and how that leads into open hardware. So there are many different ways that you could put hardware together as well, and many different forms of hardware. You could have some physical object that you have blueprints for. This is the Voyager probe, for example. You could have circuits on an integrated circuit, the individual pieces of the chip that fit together to make one integrated circuit. This is the 486, for example. You could have many components on a system on chip that have multiple integrated components that each may go together on the same physical chip of manufacture, but at the same time are in some ways somewhat independent pieces put together. So here's a relatively new SoC. This is a set of Haswell chips. You could have a set of almost software-like descriptions of hardware in the form of an FPGA, that the FPGA itself is hardware, and it is, in a way, interpreting that bit stream to implement hardware in a soft way. You can glue chips together on a board via pins, via some printed circuit board. You could have the printed circuit board itself that's designed to connect many components and connectors together. Or you can wire those boards together via any number of connectors from PCI to USB. And on top of the ways that you could put hardware together, there are many different forms of hardware as well. So just like you can compile a piece of source code to get a binary, you could have a CAD STL file that you then turn into a physical object via 3D printer or some injection molding or similar. You could have a schematic for a chip that gives you the actual circuitry of the chip, but not exactly how it's laid out. You could do a partially compiling and partially manual process to turn that into laid out masks for a semiconductor, and then turn that into a physical chip. This is the original 4004 integrated circuit. You could, again, have an FPGA bit stream and then put it onto an actual programmed FPGA and ship that FPGA in a product. You can have a PCB layout in various forms and stages that then becomes a physical PCB. And so that's an interesting distinction, that it goes beyond the notion of a compiled binary for software, because it's not just that you have a compiled binary, you have a physical object. Some of the laws apply differently. And again, all of these things are relatively easy to talk about when you're dealing with permissive licensing. If you're saying do whatever you want, then the details don't really matter. And most of the efforts going on around open hardware right now are based on permissive licensing. So I think where this gets particularly interesting again is when you start talking about copyleft. And at that point, we really have to start talking about intent. What is your goal in trying to use copyleft for hardware? What are you trying to enable? What would you like people to be able to do? And we can talk about various boundaries you might want to draw, or various pieces that you would say, well, going up to this point, we would say copyleft extends. But I would say there's few people in the room that would say that just because you have a copyleft license on a board that you should have to free whatever's on the other end of a USB connection. But on the other hand, if you have two circuits in the same integrated circuit manufactured with the same mask, that might reasonably have a copyleft license extend that far. And somewhere between there's a line or even a set of lines for different licenses that we might reasonably agree on. So in addition to those intents, then there's the question of how do we implement that? With software, we can use copyright as the exclusive right that backs our licenses, that allows us to then choose what subset of those rights we license and under what conditional grant of permission. So with hardware, the situation gets a little bit more complicated and more interesting. And with that, I'd like to hand it over to Jessica to discuss the legal implementation of that.
Thank you. No, actually, I need that. This will be a challenge. I have two devices in my hands at the same time. So hopefully, as Josh was talking, the wheels were turning in your mind. You were thinking perhaps of parallels between software and hardware. Are there actually any hardware designers or developers in the audience? Awesome. Actually, that's kind of terrifying, because I'm probably going to get this wrong, as Josh mentioned, not my day job. But anyway, since we have experience in software and in licensing, we sort of naturally look at the licenses that we know and love and that are OSI approved and think, how can we apply them to hardware? And, excuse me. Obviously, permissive licenses are easy. As Josh said, if you don't really have to worry about anything except just giving somebody attribution or credit, no problem. Copyleft is much more interesting and non-trivial because you have to think of things like boundaries. And boundaries in hardware are much different than they are in software. There are some close parallels, like Josh was saying, the perhaps two circuits or two cores on the same die that are on a board connected to some other thing. There's boundaries that are really far away, sort of easy to see, and boundaries that are fuzzier. So you need something like Copyleft, I think, in order to, sorry, I'm going to go over here. We need something like Copyleft in order to open hardware. And I'm sorry, that was a bad segue. I should have had this slide up earlier. Everyone here familiar with Copyleft Goals, right? Most important is probably enabling the study of the design in the preferred format for making modifications to the design. People need to be able to modify and distribute what they modify. The person who originally came up with the design, the licensor, should have all of the same rights afforded to them that the licensee has, and so that's something that gets protected or is ensured by making derivatives available under the same license. Not one of the official 4 freedoms, but one that we've talked about earlier today is making sure that recognition or attribution of the creative origin of a design happens. And then, of course, ultimate goal by having something under a copyleft regime is to expand the size of the open commons. I think there's a couple of additional considerations that we want to think of for hardware anyway, or hardware-specific goals, and those should be that any necessary components that you aren't going to build yourself, or so non-self-manufactured things, should be standard or readily available, so nothing made of unobtainium or that's available only in minimum purchase quantities of 100,000. So I would say those would be goals for open hardware. Josh was talking also before about how exactly we make these things work. And we know that we use copyright for software. Copyright under US law, well, actually under all laws, grants the creators certain exclusive rights. And the fact that people have exclusive rights mean that they then have something that they can choose to license with others. So, really quick review, because I know even though, I don't know, how many people are lawyers in the audience? Fewer than hardware developers, but okay. So even so, most of you guys probably know this stuff too, but in the interest of completeness, I'm going to talk about each of these sources of exclusive rights for authors and creators. So copyright, patent, mask work, which might be one that's kind of new to folks, and trademark. So copyright, just again as a refresher, there's 5 exclusive rights. 3 of them are probably most important for both software and hardware. So that's reproducing the work, distributing copies of the work, or creating derivative works based on the work. Subject matter for copyright, there's a whole lot, but really 2 are going to be important for hardware. And those are literary works, and that's probably or primarily going to be important for the software that is going to enable hardware. And by the way, I'm sorry. Assumption that everyone was thinking that I'm talking about electronic hardware. I'm not talking about just a plain physical object that doesn't have any circuits in it. Literary works and the pictorial, graphic, and sculptural works. And then just for completeness, in case anybody is interested in what the entire scope of US copyright law covers, I listed the other subject matter. The next source of exclusive rights for creators is patent law, and that gives inventors the exclusive rights to do 4 things: make, use, sell, or import the inventions. And there's 4 areas of subject matter under patent law. Most likely, thinking about hardware, machine, and manufacture are going to be the applicable ones, but process and composition conceivably could also have to do with hardware. So you might wonder, open patent excludes people. Why would you possibly want to patent something that you want to open? Which is a legitimate question. And the reason that I can think, if you didn't already have a patent, the reason why you might want to go get one is so that, assuming that you had a hardware design that you had licensed under copyleft terms, if someone wasn't fulfilling the copyleft terms of that license, and you terminated their license, you could still have rights under your patent to go after them for some sort of damages. But patents, again, sort of contrary to free and open, they're also expensive and time-consuming to get, and they only last for 20 years. But all is not lost, so it's not like patents are totally useless. You could file for a patent and then never get one, or even not actually filing for a patent, just publishing your design can serve an important purpose in terms of keeping hardware free also. And so that's, you know, the idea of defensive publishing or putting something out there and making it prior art. And I put a little plug down in the bottom corner of my slide here. There's actually a presentation tomorrow from the, what are they called, the Open Patent Project, where they're going to be, excuse me, talking specifically about this subject. So I would definitely check that out if you're interested. I know I'm going to be there, but patents don't make a ton of sense, but again, have to talk about them in the context of exclusive rights. So MaskWorks are interesting, and MaskWorks actually came into being in 1984 because of the Semiconductor Chip Protection Act, which internationally semiconductor chips are protected under something that's called TRIPS, and what the acronym stands for right now is eluding me, but oh, so close, but yes, okay, there's an S there too. But anyway, came into being to protect chips, and it's sort of a hybrid between copyright and patent. It doesn't give you all of the same exclusive rights of either one of those. But the important ones are that you can reproduce the mask work and import or distribute a semiconductor chip in which the mask work is embodied. So it's kind of interesting. The mask work doesn't give you any exclusive rights until it becomes embodied in the chip, but then once it does, you have rights to keep other people from basically cloning your product. Interestingly, you might have noticed that there's no language about derivative works there. Mask works do not give you the exclusive right to create derivative works. And reverse engineering is allowed underneath the SCPA. So it's conceivable that someone could, you know, take a chip that I build and reverse engineer it or study it, make significant modifications to it, and then build, you know, their own and ship it and sell it. But the one thing, or one of the things that stands in the way of that is actually making chips is really expensive and really hard. So I think at the time that this law came out, or that this was enacted, it was a bigger deal. I think maybe it would only cost like maybe $50 million to reverse engineer and make a chip. But I think that figure has grown exponentially since then. And subject matter, again, a mask work is something that's fixed in a semiconductor chip. That's the only thing that mask works apply to. And last but not least, trademark. Trademark, the exclusive rights associated with that are the exclusive rights to use a mark. And a corollary to that then is the ability to prevent the use of that mark or a confusingly similar mark by another party. Subject matter for trademarks, a word, name, symbol, or any device used to identify a product. The thing about trademark, as opposed to the other three sources of exclusive rights that I just talked about, this is the only one that I don't think is a really good candidate for opening. And the reason for that is that trademark it's associated with you, your brand, and your identity. So you don't want people to be sticking, you know, your trademark on a product that doesn't live up to your quality standards. But it also indicates a single source of origin, which is not really consistent with the whole principle of open development, right? Which is a sort of decentralized and multiplayer, multi-party model. But I felt I would have been remiss if I didn't talk about trademark at least a little bit. So there it is. That's the last I'm going to talk about it. So now that we have our foundation, or we've been reminded of the sources of our exclusive rights in various objects, let's talk about hardware and forms again. So actually, let me go back one second. For those of you who aren't hardware engineers, the difference between developing software and developing hardware, the biggest difference seems to me, and again, this is me as a layperson, is that there are a lot of different steps involved in creating hardware. And those steps, interestingly, different tools are used at different parts along the journey, and different exclusive rights can attach at different places. And to me, that's interesting from a legal perspective, because potentially you can put different licenses on things at different parts. And depending on where in the stream you're combining things, there may be different effects happening. So Now I can talk about printed circuit boards. PCBs, I think, are a really good example of what I was talking about, where there are these different steps that have different artifacts that get created that are potentially protected by different exclusive rights at different stages in the process. So you start out with your schematic capture, which is basically just representing the logical design of the circuit. Can't copyright or can't protect a circuit. It is a fact. But the graphical representation that I've put out here is something that could be protected by copyright. The output of the schematic capture process, there's, I guess, usually three. One would be a proprietary design file. Another would be this graphic, so something that's usually like in a PDF or JPEG format, a visual representation of the circuit, and then netlist and component information files. The proprietary file, the design file, and the diagram are, like I said, they're protectable as expressive works. The netlist and the component information probably aren't protectable because they're so functional. But interestingly, the netlist and the component information are the important, wait, does this have, yes, the pointer, okay. Those become the input to the second part in the PCB process, which is the layout, where the designer is actually coming up with the physical implementation of how the circuits are going to work. And it's not really dark in this room, so you can't really see how complex it is, but it's really beautiful. No argument, I think, that a certain degree of artistic skill and creativity is required to place, routes and figure out where components are going to go. The output of the layout process are a series of files called Gerber Files, and what they represent, most definitely the fruits of that creative and artistic labor, are protectable by copyright. And since copyright gives us exclusive rights, that means you could license them under a copyleft regime or any other open licensing regime of your choice. And then last but not least, those Gerber files get fed into the tooling at a PCB manufacturing house, and they make your PCB. You have this manufactured board that embodies the design. The actual board itself now is no longer protected by anything, although I suppose if it was sculptural or really expressive in its shape, it might qualify for protection under the pictorial, graphic, or sculptural works, but probably not. Basically, the only thing at this point that would be eligible for any sort of exclusive rights would be any designs that you had screened on the surface of the board. But anyway, PCB, an example of the multiple stages, the different artifacts that get produced, and in this case, they're actually all protected by copyright, but examples of the different exclusive rights that could attach at different points. So silicon then is interesting. We'll start with talking about MaskWorks over here on the left. Oops. Dang it. Left, I had, there we go. A picture of a maskwork. Remember, maskworks don't actually have any, masks don't have any protection under that maskwork law until they actually become fixed over in the piece of silicon, which you see on the right. But over here, just when it's existing as a mask, this could be protected under copyright, right? And then over here on the right, again, final product. Here you get the maskwork kicking in, and it's protectable under the SCPA provisions. But before a maskwork even exists, before you start to build the masks, you start out with the design of the chip. And one of the things that I think is testament to how difficult and time-consuming it is to produce or to design a semiconductor chip is the fact that what has become really a large industry in and of itself in the tech industry is the licensing of cores, IP cores, which are usually broken into or referred to as either being hard or soft. But these are designs that are made by third-party vendors, or there's, some companies, all they do is cores, other companies do a variety of things. But the idea is that they are pre-configured or pre-designed blocks of IP that can be dropped into designs, thus enabling people to design more quickly. You see up here, oh, dang it. I keep wanting to push the other thing. On the upper left, this is a drawing of what's supposed to be a system on a chip. And you can see very distinct blocks in here. Those are cores. Those are representing hard cores. And the things that's interesting to me, anyway, about cores and whether they're hard or soft is, well, they affect the way that the licenses might work on them when you use them in a design. The hard cores, again, you can see how they're very distinct. If you have a hardcore IP block that you basically drop into a design and you interface with the rest of the design using standard interfaces to communicate, then it stays pretty discrete, stays by itself. If you had a copyleft license on that IP core, it wouldn't be extending the copyleft terms to the rest of the cores on your silicon. But what if you had a hard core that you put into your design, and it turns out that you couldn't use standard interfaces in your design? You had to make modifications in order to make that core work. Well, then those modified interfaces would probably become a derivative work of the copyleft core, and then you would have copyleft obligations spreading beyond that core and going at least to the interface that you had to do, so requiring you to make the sources available for that. Soft cores, on the other hand, are, well, they're more like software. They're malleable. They're in an editable format. And down here, I've got a picture, the same picture Josh had of an ASIC. You can see there's definitely some hardcore logic blocks in here, but then there's a whole bunch of other area that is more tightly synthesized. There's been a lot more integration that happens when you're using soft cores, and engineers, correct me if I have this wrong. But the nature of the soft IP, because you're getting it in HDL, you're getting it in the human readable form describing the circuit, is that actually it's going to influence the design, the rest of the design, and the rest of the design is going to influence it. There's sort of this interplay. Which, if you think about it in software terms, it's very much like commingling, or what would we say? It's not even linking. It's like taking snippets and merging things together. So I think if you're using a soft IP core, you're almost guaranteed to have a derivative work. So again, you could have a spread of copyleft. You could open up your design way big. If you didn't want to have your design be open, but you wanted to use a soft IP core, what you might do is take the soft IP core and try to harden it up before you put it in your design. I guess that would be one way that you could sort of try to minimize the boundary creep or the boundary encroachment. But anyway, those are the differences between hard and soft IP as I understand them, and I just thought that was really interesting.
It's worth mentioning as well that this is another place where your intent matters, such that it's reasonable to ask, as we develop more understanding of how to apply copyleft to open hardware, where we want our licenses to extend. We may reasonably want hardware equivalents of the LGPL as well as hardware equivalents of the GPL with, tighter and looser boundaries for how far they extend. And that would play nicely into this as well.
Sorry, the thing that I forgot to mention, and this is sort of unfortunate, but you reminded me when we were talking about intent. All of my great intent to have an open design is going to be for naught, or maybe for naught at the end here, when I get down to actually finishing up my design using my EDA tools. All of the tools have proprietary libraries in them. So when I combine, whether they're hard or soft IP cores that I licensed, whether it's, I did the full design myself from scratch, when it comes time to combining them with the libraries from my EDA tools, I may very well end up with a derived work that now is going to have license compatibility issues because, like I said, all of those EDA libraries are under proprietary licenses. So I have a couple of options. I could choose to license or make my cores available under a permissive license because that makes things easy. Or maybe I could make them under a weak copyleft license. Or another possibility, not sure if we can actually take this as gospel, but what if we had what if we had a system, the equivalent of a system library exception for cores? so a core library exception. I'm not sure if you could read the Gpl V3 as enabling that, but if you could, that would be great. And just by the way, the Gpl V3 family of licenses is the only OSI approved licenses that mention MaskWorks in them, which I thought was interesting. So they were kind of thinking ahead to hardware. Related to the library problem that I mentioned for my soft and hard IP cores, I run into a similar problem with the Fpga down below. And so we've got the piece of silicon that's built over here. You got to program it with a bit stream. There is no open tooling from any of the major FPGA vendors to enable the creation of a bit stream to put into the FPGA. So once again, I could have done all of my other design, have it be opened, but then when oh, okay, you're going to correct me?
Not for the big ones, but at least for the latest ICE 40 we have.
Yes. Yes. Well, and that, are you from the Ice Storm project? Okay, but you know about it. No. Okay, so here's a problem. So again, I can't program my FPGA without getting in trouble. So really, the best that you could possibly do, I think, if you were coming up with the design for an FPGA, would be to make your HDL designs available under an open license, and then provide instructions for your users how they could create the rest of the design files and how they can generate the bit stream. Although that still doesn't solve the problem for them, it's just moved it over to the right. Now they're the ones who are going to be creating the thing that has the proprietary libraries mixed with the open license design. I suspect that the absence of or lack of clarity around whether we have a core library exception is why most of the cores that you see available under open licenses are either permissive or LGPL, because I think either of those licensing schemes sort of gets around the problem. And yes, okay, so open hardware. There is actually an open FPGA. The Ice Storm project guys reverse engineered Lattice Ice 40 FPGAs, so they figured out how to do the bit stream. And this is actually a picture of something called MyStorm, which a guy named Alan Wood created. Fully open piece of hardware. You can see the open hardware logo on it. So if you were so inclined, you could get the schematics, get the Gerbers, get your files over to your PCB house, build your PCB, order your Lattice semiconductor for like what, I don't know, $15 or something, and then you can program it. And
the internals of the chip are not open, but everything you need to program on is.
No, the bit stream, that magical last part isn't open, not on Intel. Sorry, but that's a great question, and we ask our friends in the programmable solutions group, hey, would you open the bit stream so we could do that? But no, even Lattice hasn't opened it, right? It's the guys at Ice Storm who reverse engineered it, because again, reverse engineering is allowed under the SCPA, but no vendor has opened their bit stream. If anyone wants to volunteer to reverse engineer an Altera FPGA or Xilinx, that would be awesome. Sorry, so back to my hardware design. An enclosure might be another thing that you have in your hardware design. So an original design created in a CAD tool, or it could be like a scan of an existing object. Whether or not your enclosure or your physical thing is going to be able to be protected in any way, or whether your design files representing the object are going to be protected, depends on a couple of things. How it was created, again, whether it was native in the tool versus a scan of an existing object. I'll give you a hint. If it's native in the tool, might be protectable. If you just do a scan of an existing object, not going to be protected. No matter how much skill or creativity or art was required in making that scan, you haven't done enough transformation to make it eligible. And then whether or not your design file or the design itself are going to be able to be protected by anything. They're going to be looking at whether it's totally useful or creative, or where the balance is between the two. And courts would do a separability analysis to determine whether copyright was going to apply to anything. In this case, I think we would say that probably the Intel logo is, well, it's already protected by trademark, but my design file containing it would be protectable and licensable under copyright. Just the interesting thing in this example, actually, this isn't an Intel design. This is some guy who is infringing on the Intel trademark. But I thought it was nice, and I'm not going to report it because it's in support of an Intel open hardware project. So I'm going to wrap up briefly before I hand it over to Josh. I just wanted to talk about the state of open hardware licensing today. So what would happen, intellectual exercise, if I had a chip today that was built on an open design and I sold it, or I had a PCB that's built on open designs and I manufacture the PCB and I sell it? What would happen? Or what does the person who makes the stuff have to do with it? Well, the answer is actually they don't really have to do anything if unless I license the design under either the CERN or the Tapper open hardware licenses. All of the other licenses that are currently available or that are designed for hardware, plus the Gpl V3, don't extend beyond the documentation. They don't extend beyond the digital. They stop at the hardware, which I think is unfortunate because I think the goal of open hardware shouldn't be just that you can build it, but once you've received the thing that's built, you should be able to understand how it was built. So I just have a little table here summarizing the source availability requirements, which again, I think are really key. Whether or not the physical hardware gets treated like a binary, under the GPL is the source required. Whether or not you can use it for any purpose, that's an important one. For some reason, the Tapper one doesn't have that as a requirement. But also having the license be compatible with copyleft software licenses, because again, it's an electronic device. I'm imagining that I'm going to have hardware and software working together. So over on the far right, I have my ideal hardware license. You see it has yes all over the place, but I also am going to make a specific core library exception so that I solve my problem with the cores. And yeah, if anyone wants to take a stand at writing that license, that would be awesome. I'm actually the last person who wants to encourage license proliferation, but I do think that to make open hardware truly work, we may need a revised license. Now I'll turn it back to Josh.
So one key question you might reasonably ask is, why do we care about license compatibility? As mentioned on the previous slide, one of the issues is that the Tapper open hardware license, for example, explicitly has some restrictions on what you can use the resulting hardware for. And as a result, it's a license that would not actually qualify as an open source or free software license. The Tapper folks would say, well, it's a hardware license, those don't apply. But I think that there's a key requirement here that is becoming increasingly important. We want to support the ability to copy freely between hardware, software, firmware, documentation, specifications. You may want to take some key piece of the hardware description and copy it into the spec in order to document something, or copy something into the comment of a piece of source code, or vice versa. And the boundaries between those become fuzzier over time. FPGAs become more important. Hardware is described with software. There's the running phrase that you might have heard that software is eating the world, and in some ways it's kind of eating hardware, but hardware is not going quietly, and there's still a very interesting subset that is firmly in the hardware design space. So the ability to have these interoperate is very critically important. We want to have compatible licenses for these. So I'm going to echo the same thing Jessica said, that we certainly do not want people going off and writing their own license from scratch any more than we would for software. But if you are, one of those precious few people who are doing revisions of a existing well-established software license, please seriously consider accounting for hardware in those new revisions, and in particular extending those provisions in ways that make sense, such as treating physical hardware similar to a compiled binary with respect to provisions like copyleft. So with regard to the open hardware C ecosystem as a whole, we're still very much in the early days of open hardware. Most production designs still do include some proprietary components, whether it is some part library or some portion of a circuit, or whether it's simply the fact that all of the individual ASIC chips on the board are not themselves open. then we're still very similar to the very early days of free software, where the GNU project was a set of more usable, more friendly free software tools that sat on top of proprietary Unix systems, and they existed within that ecosystem that was kind of carving out a niche of free software. And hardware is still in the same vein of, here is a little niche of open hardware that is carved out within a broader proprietary ecosystem, and we want to push to make that more open. So along those same lines, one of the critical needs for open hardware that we'd be really interested in seeing people work towards would be more open source parts libraries, and we think Copyleft would go a long way towards growing that ecosystem and building that up to be something that can interoperate with itself very well. So, as said before, we're primarily aiming to provide all the right questions rather than saying that we have all the right answers. But at the same time, we do have some specific recommendations. So in particular, for chips, if you're doing any form of ASIC design, whether on the small scale or large scale, if you want Copyleft, the Gpl V3 is currently the best choice of license because it's the only license that actually mentions MaskWorks and covers all the way through to hardware. It's not perfect since it does not necessarily extend the provisions to force the distribution of source code to anyone who has the physical chip, but it still goes further and fits better than any other license out there, including the Creative Commons licenses that have commonly been used for hardware, which don't really include any of those provisions. For PCBs, you could absolutely use a Copyleft license if you like. It's a good statement of your intent, and many people will respect your intent whether there is an exclusive right backing it or not. Unfortunately, or fortunately, depending on your perspective, PCBs as in a physical object form are not actually protected in any way. On the one hand, that's not necessarily a good thing for Copyleft. On the other hand, that can be a boon to the maker community that does do reverse engineering and development of, let me build a compatible board for this random chip. So it's a mixed blessing. We would definitely encourage the development and contribution of open parts libraries to try to get rid of that proprietary substrate that open hardware is still built upon. And if you are drafting a future Copyleft license of any kind, definitely account for MaskWorks or any other similar present or future legal structure, and treat physical hardware like binaries, require the source code for it. So with that, I'd like to wrap things up and invite any questions or discussion. I think we may have time for one or two questions.
So hard to say.
Hi, Josh. I have a very basic question. I don't even see the point of Copyleft hardware. I've written stuff under GPL and I've put it out. I've been working on this for 20 plus years, but I don't. When I put stuff in Copyleft in software, it frees up a lot of the barriers. Namely, people are free to do whatever they want with it, and it costs nothing all along the way. That's not the case for hardware. I mean, even if I put it on Copyleft, there's the things I'm preserving are not the same, and I'm not even sure the value that I'm bringing to people by doing so. There's an argument that can even be made that by preserving some of the rights, I'm actually enabling myself to create cache reserves that allow me to create more of what people like.
So you could also argue that by keeping your software proprietary that you are developing funds for future development, and I think it's basically the same argument. Honestly, we're in the really early days of open hardware. We're in the very later stages of open software. The ecosystems look so different right now. They looked so similar back when open software was first being developed that when you're developing early stage software and it is mostly duplicating things that exist but making them free, the value of saying, hey, this is copyleft, this needs to be kept open, it seems like you have a smaller item of value and a smaller case to make for it. But at the same time, building up that ecosystem and eventually building up pieces of hardware that are difficult to replicate and easier to work with in an open form, that if we want to encourage a broader open hardware ecosystem and encourage pieces of hardware that would otherwise be proprietary to be opened up, then we're in a position where copyleft potentially gives us some leverage we wouldn't ordinarily have. So in particular, using permissive licenses would...
I mean, copyleft in software commoditizes something that exists. Even if you copyleft hardware, you can't commoditize it. People will have to pay for it anyway.
You have to pay to manufacture it, but at the same time, again, software is eating the world in a way. FPGAs don't require any additional cost each time you program them. So as you're doing hardware development on FPGA...
One quick question and then wrap up.
Yep, sure.
I use the Capra license extensively, and I believe you when you say that it doesn't meet the requirements you have. Can you provide me the rationale for why it doesn't work? Not here, but externally.
I can tell you the reason why it doesn't work for me. It's very simply, it wouldn't be free because
Use the mic, please.
Okay. It has a restriction on use. It has to be for a lawful purpose.
No, it doesn't actually.
They don't.
It's written into the license.
It's written in the license.
Oh, for any legal purpose.
Yes.
Yes, exactly.
Yeah. So that otherwise, I'm okay. Okay.
Yeah, it's the same thing that came up in the context of software with respect to like the Hacktivismo license, where they said you can't use this to do human rights violations. But the problem is the people who would do that don't care what the license says. So
Yeah. No, that's the only complaint about it.
I read that, right?
yeah,
Oh,
that's
yeah.
the one.
That's
That
the
is
one
the
thing.
one reason why it doesn't qualify as an open source software license.
Okay, great.
Thank you.
Thank you so much, Josh and Jessica.